Hey, James. So I was reading this document about energy grids, and it mentioned this paradox, like renewable energy, which is great, right? It actually makes the grid more unstable. It kind of blew my mind, really.
Right, it's completely counterintuitive, isn't it, Emma? The thing is, well, solar and wind are fantastic, absolutely, but they're erratic. They don't always produce power consistently. And our current systems, they just can't manage that complexity in real time. It means fragile infrastructure, higher costs, and crucially, folks losing power when things go wrong. It's a real challenge, frankly.
Yeah, I can totally see that. So, what's the big idea here? How do quantum microgrids, even fit into solving this? It sounds super sci-fi, if I'm honest.
Well, it's not sci-fi anymore, thankfully. Quantum microgrids, they're essentially merging the local resilience of traditional microgrids with the sheer computational muscle of quantum systems. Think of them as living labs where the theory really meets practice. They're not just these technological curiosities. They're proving grounds for national strategies connecting energy security, sustainability, and digital competitiveness. It's quite exciting, actually.
Okay, living labs. I like that. So, are there actual examples of this happening right now? Like real world applications, not just in a lab?
Absolutely, Emma, loads of them. Take Israel, for instance, with Quantimize. They're tackling battery degradation, which is a massive headache for renewable storage. Using a quantum annealer, they've figured out optimal charging and resting cycles, which reduces battery cycling by like 40%. That's huge for longevity, fewer blackouts, and more reliable integration. It's all about durability, maximizing asset lifespan, you see.
Wow, 40% is really impressive. That's a game changer for battery life. What about other countries? Is anyone else doing something similarly impactful?
Oh, definitely. China, for one, in Xinjiang. State Grid Xinjiang and Southeast University are using this thing called the Quantum Approximate Optimization Algorithm, QAOA. It's for precision scheduling, like coordinating solar, wind, and storage in real time. Traditional schedulers really struggle with unpredictable weather, but quantum-enabled scheduling dynamically adjusts. It ensures smoother power flows, better cost efficiency, and a truly resilient grid. Their focus is scale and reliability, making massive renewable networks dependable even when it's pretty chaotic out there.
So, Israel is about durability. China's all about scale and precision, which makes sense, right? What about something a bit more community focused or like general grid resilience?
Excellent question. Germany's Q-Grid project, funded by the BMBF, is a fantastic example of community. They envision neighbors trading rooftop solar power peer-to-peer. Quantum computing helps decide where, when, how energy flows, essentially building self-organizing, self-healing grids. It's not just about efficiency, it's empowering local autonomy, moving away from top-down control. It's quite revolutionary, actually. Energy democracy, if you will.
That's super cool. Neighbors trading energy? That's totally the future. And what about recovering when things go wrong, like storms or cyber attacks?
That's where companies like D-Wave come in, globally. Their hybrid quantum classical solver, the CQM, helps restore power really quickly after disruptions. It reroutes flows, balances demands, and optimizes recovery plans in real time. It doesn't replace traditional methods, mind you, it just complements them. It allows operators to respond to crises with incredible speed and flexibility. It highlights how quantum technology just excels when you combine it with classical systems for real-world solutions. It's really about resilience through hybridization.
Okay, so these quantum microgrids, they sound like they're not just theoretical anymore. They're actually happening. What's next for them then?
Exactly, Emma. They're fully functional test beds, rehearsing tomorrow's energy systems today. The next decade is going to be incredibly exciting. We'll likely see far more integration with AI for forecasting and really adaptive grid management. Think about it. AI predicting demand, quantum optimizing the supply. Very powerful.
Oh, that makes so much sense. AI for the brains, quantum for the heavy lifting. Will there be any other major shifts or challenges?
Definitely. Quantum secure communication is going to become paramount to protect these grids against cyber threats, and we'll need robust standards for interoperability to ensure these quantum-enabled microgrids can scale globally. The whole story is one of convergence, really. Local microgrids as the laboratories, quantum computing as the catalyst, and national strategies as the drivers. It's building an energy system that's not just cleaner, but smarter, fairer, and much more resilient against any disruptions. It's a big deal.